Hey everyone, I'm Aaron, and I'm here with with DataStax again, and we're going to do a session today on building out real-time generative AI product recommendations. And the goal, of course, is to boost cart size, boost sales. Of course, with Prime Week happening recently, maybe this is a good topic, good right on time, top of mind for everybody. So yeah, let's get started and talk about how some of our solutions that we have at DataStax can help with that. So what I'm going to be using as kind of a stepping stone or a foundation today is if any one of you have been around long enough to have joined some of these live streams years past. We actually did an e-commerce workshop that was like a 4-part series where we started out and like each week we like built a different subsystem onto like this whole big site. So we are actually going to use that material today. I've gone ahead and made sure that this site like spins up and it works. I actually have my own branch of it that allows me to do some some prototyping, which is the one that we're going to be focusing on today. That's going to allow us to go ahead and add some vector search functionality. Actually, I've added the vector search functionality a while ago, but I did put a new method in there for today. Oh, C Lam is from Minnesota. Hey, I'm from Minnesota too. Outstanding. Good to see Minnesota represented. All right. So anyway, that's what we're going to focus on today. We're going to use the old e-commerce workshop that we did years ago, and kind of show that how it's been revamped to support vector search, GenAI, and how to use those, put those to use in the use case of customer recommendations. So our approach is pretty simple. We'll talk a little bit about legacy approaches. I have seen, before coming to DataStax, I worked in e-commerce for a very long time. And I've seen a lot of different technical approaches to things like product recommendations. So we'll talk about some of those older approaches. We'll go ahead and talk about a simple product recommendation solution that uses vector search. We'll maybe talk about how to personalize those recommendations by like augmenting it with like customer order data. And then of course, some additional considerations that you might have, just more around the line of like, understanding your business logic, and kind of how that plays into building a good product recommendation system. And then I'll go ahead and actually show you that e-commerce website code that I have here that we can run, as well as some of the methods behind, excuse me, how we do things like generate embeddings, how we run a vector search for like an ANN or approximate nearest neighbor, and then also how we can maybe even like build a quick chatbot using something like Langflow, which is also a DataStax product too. So anyway, so that's kind of our approach today. All right. So, like I said, I've seen a few different legacy approaches here. One that I kind of have like one listed here, and that's it. I will say another one though. Another common one was, marketers would go into like a product database and like list out like related products, and it would sit there in like an array that was like attached to that row of product data, which was a very, very manual process. Not quite as manual, but also not fast is, oh, sorry, I don't know which side my window is on. I think it's this side. Yeah, there we go. Is this one. I worked for a, well, if you check my LinkedIn, you can kind of guess who it was, but I worked for a really big box retailer that I'm sure you all know. And when I got there, one of the largest Cassandra clusters that I supported was for this recommendation system that basically all it did was hold the results of this gigantic MapReduce Hadoop job that ran like every 4 days or so. So what it would do is like compile statistics on, where every customer on the website went, what they added to their cart, And it would try to help establish relationships between customers so that if you added something to your cart, it'd say, hey, other people who added this to their cart also had this in their cart or also like this. It was a way to like establish those relationships. But of course, that job, like I said, it took like 4 days to run. So as soon as it got into production, as soon as that data got out there, it's already 4 days old. I mean, I guess, recommendation data isn't something that has to be like up to date, but when you're talking 4 days old right off the bat, that that's just begging for a different solution. So anyway, generative AI gets us around other way, this. All right. So simple solution for product recommendations. The first thing you need to do is to generate vector embeddings. Now, we've all been at this for a few years now. So if you're new to the whole like AI, Gen AI space, and you're not quite sure what vector embeddings are, basically it's a very, very long dimensional array of floating point numbers, and those floating point numbers represent data. So you can go ahead and you can take a product and take its name and its description, and you can use that to generate a vector embedding, which is basically just a numerical representation of that product data. And then what you do is you can get all of your products with those embeddings, and they all share what's kind of called a vector space. And when you run it in something like a vector database and you do a vector search on it with an ANN or approximate nearest neighbor, like cosine based algorithm, what'll happen is it'll bring back products that are closest to that product in vector space. And that's kind of how vector search works, and kind of a little bit about what vector embeddings are. That's the quick, like, I don't know how long I've been talking, 45-second version. So if you want to understand that a little bit better, I absolutely recommend reading up on that. And Rajesh wants to know, why did I choose ANN and not KNN or FIAS? ANN is really what we've been focusing on in our products that we offer for the past few years. So that's really kind of the main one that I'm going to talk about today. So, good question. All right. So let's say that we've actually, did I get ahead of myself? I got ahead of myself. Oh, yeah. So we generate embeddings. We query for a product. We query, 4 products, by one embedding. And then we can ANN search for similar products. That's simply put how we could get something like this to work. And I'm going to show you that in the code, actually. The second approach that we're going to see too is how to make those more personable, because you can go ahead and you can take products that you have and say, hey, well, this product is similar, but that may or may not be relevant to whichever customer happens to be navigating on your site at the time. So one idea too that you can use is to go ahead and aggregate some of your customers' order data and try and find like their most ordered or most viewed products and drive recommendations off of that instead. That's a way where you can kind of get a little bit more focused recommendations. And I do have a method that that I've written and put into play that I can show you how that works too. All right, additional considerations. One thing I've found is that when you run a vector search, the first product that comes back is actually, let me back up just a second. When you run a vector search, all of the products that come back are going to have a similarity score associated with them. Depending on which vector database you're using, or vector search algorithm or library you're using as well, like DataStax, Astra, and Cassandra, both use JVector, and in JVector you can get the similarity score returned, and that's optional if you want that back or not, but sometimes it's a good idea. Anyway, the first product that comes back with a 100% match is always going to be the product you searched by. So one thing I always recommend to people is that, hey, if you're going to give this a shot, always remove the very, very top result, because it's really not going to be relevant to recommend the product that you just searched on. That's one consideration that you want to think about from a logic standpoint here. I talk a little bit about understanding your business and your data, and a little bit about the business logic. That kind of goes into play with this a little bit. The example that we're going to show is mostly like retail clothing. So you're going to see a lot of T-shirts. I think I have some hoodies in there, and maybe like a track jacket or something. Well, the thing is that many of those products are in there several times, because you'll have, let's say you have like a DataStax T-shirt, right? And let's say that it's in there, size large. Well, if you do a similarity search on that DataStax T-shirt, the closest products you're going to get recommended back are the same shirt, but size medium, size small, size XL, size 2XL, et cetera, et cetera. So you'll kind of want to have to understand your data and how it's going to come back. The method that I'm going to show you today, I actually go ahead and look for in the results that come back. I keep going down the list until I find one that has what web marketers call a different product group. And that product group is actually going to be a completely different product, and not just one that's sized slightly differently. So that's kind of where I'm going with. Make sure that when you do something like this, you kind of understand your data as well. And some products, we just shouldn't recommend. I have a picture of a toilet there. I remember somebody posted on Amazon, or sorry, not Amazon, on X a couple of years ago, I think. And they said, hey, yeah, Amazon, I just bought a toilet like a month ago, but that doesn't mean I constantly want toilets recommended to me. A toilet is one of those things that once you buy one, you probably don't need to buy another for a really long time. So, again, it's more about understanding your product data and and understanding your customers' habits as well when you go ahead and you build something like this. Basically, don't build it in a vacuum, right? Talk to your product marketers and make sure that they understand what you're trying to do here. I know that one thing that we used to do when I worked at Grainger. Oh wow, this is like 15 years ago now or more. We actually used to sort the product result sets on a search by price, so the highest price came up first. And I think there was like a tools category or something where we had like power drills or whatever. Well, the top product that would always come back was like this super expensive industrial drill press. And each one was several $1,000s. And our chief of marketing was just laughing at that, like, wow, you guys are really promoting that drill press. And we're all just like, hey, all we have to do is sell one, right? And that'd be pretty good. Anyway, I digress. But the point is, make sure that you understand your product data and a little bit about the business logic that goes behind it. One thing too is that you can also go ahead and build a I know for AI use cases, the chatbot has been done to death, but a shopping assistant, again, okay, also kind of a chatbot, but a shopping assistant that has access to the context of your product data can actually serve as like a conversational search interface to help your customers find what they're looking for. And again, it's all only as good as the data that you put into it. And again, I'm gonna demo how to do that or do something like that in LangFlow, actually. Let's see here. Wow. Well, I didn't have a whole lot on the slides there, so we've made it through those in 14 minutes. But basically, this is what we're going to have a look at. Is we're going to go in depth inside this e-commerce workshop site that I have and that we've been building for years. We're going to take a look at the underlying CQL schema. Talk about what it takes to generate vector embeddings and show a little bit of the code. And then I have a couple examples of vector search as well, and we can go ahead and look at some Spring Boot methods that I've built out that actually kind of use that vector search, and we can take a look and see the results that come back. And then time permitting, and I'm guessing we're going to have time, we can go ahead and have a look at LangFlow as well, where I kind of take that same exact data and put it into a chatbot and just kind of show how easily that all comes along. So let's take a look here. Let's make sure that I'm signed in to Astra properly. All right, and we'll have a look at e-commerce. This is taking a little bit to come up here. Why don't I just fire up the CQL console? I bet you that'll come back a little bit quicker. Yeah, that is a little slow. How about that? There we go. All right. So let me jack up the fonts a little bit here to help all of you out at home or at the office, wherever you are, to maybe see this a little bit better. So let's go ahead and do a use e-commerce. Uh-oh, am I in the wrong one here? Oh, you know what? I might be. Yeah, all right. I know what I did here. Okay, let's go back to here and maybe try this one and then CQL console. Come on. Hey, there we go. All right, so now let's go ahead and do a use e-commerce. Hey, there we go. Outstanding. So if we describe the tables that we have, you can see that we have plenty of these tables out here. Actually, this schema, you can see it out in my GitHub repository. So this, and I'll have this link available in the slides as well. But you can see this is the workshop e-commerce prototype that we've had out here, and yeah, you can see that we've had some commits as long as like 4 years ago. So this thing has been out here for a little bit. But if you scroll down some, you can actually see the individual slides from the webinars that we ran eons ago. But if I have a look at create your schema, you can see, I mean, it gives a little description on how this is all going to work. But the schema that you have to put in the key space is all like listed right here. So you can see, how this all, kind of works out and what we're going to put in. As well as, putting the data in itself. You can actually run these CQL statements and get them in there. But if I go here and say, hey, let's do a select star from product, and I'll just do a limit. Now let's just do a limit 2 on that. Okay, so you can see this is a little bit about like what our product table looks like. Where we have our product ID, brand name, images, some linked documents, description. I learned a lot from being in e-commerce for a lot of years that you'll have a long description and you'll have a short description, and some other things that are in here as well. One thing that I can do is if I take a look at if I describe this table itself, you can see that, yep, we have, just a simple primary key of just product ID. And the rest of it is pretty straightforward. Now, what I've done is gone ahead and written like a special, not really like a job, but kind of a batch program that goes through this product table and goes ahead and creates vector embeddings. So if I jump over to good old Eclipse here. All right, and we have a look at this test embeddings here. If I scroll down a little bit, you can see that I'm creating this embedding model object from the Hugging Face embedding model and using the builder on that. And we're going to be using the sentence transformer, the All Mini LM L6 V2 model. This is actually a smaller dimensional model, if you will. It generates vector embeddings that are 384 dimensions. In terms of other, if you haven't worked with a lot of large language models before, you'll find that a lot of them are in like the 1024, 1536, even 2048 kind of range. So 384 is not that much, but it's like it's a good way to get your feet wet. If you're just starting with something small, All Mini LM L6 V2 is not bad at all. Of course, the more dimensions that you have available to create larger embeddings, the more accurate, depending on your data, of course, but the more accurate your results generally are. Of course, the advantage of a smaller dimensional model is you will get a little bit of a performance boost off of that. So there's a give and take when you pick your model. I find too that if you go to like Amazon and you're looking at all the models on like Bedrock, read their descriptions. A lot of times it'll tell you a lot of this stuff about, how it'll perform, and what good uses are for it too. So it's good to go ahead and give those a read. All right. Oh, by the way, I'm using LangChain 4J here. That's kind of the model interface that I'm using. And really what I've done is I've exported that data that we saw into a file. And, we're going to go ahead and just iterate through that file. And really all it is just taking the product name and using that product name to generate a vector. That's it. And then, of course, at the bottom here, you can see that we're taking that vector and we're putting that into a new table. It's going right back into AstraDB. So if I were to jump back to Astra here and say, let's do a describe table. Oh, I want to spell table right. And we can say product vector. Oh, vectors plural. Yep, there we go. So this is a little smaller representation of what we saw before in the product table. It has a lot of the same things. So when I built this table, I thought a lot about, I took the traditional Cassandra approach of, hey, let's think about what data we want to come back and get exactly that so that we don't have to go get other data like images and things like that if we really just want to show this quickly. And here you can see I have a product vector with a vector data type, and you can see it's a 384 dimensional float. So 384 floating point array is on this table, and that's what we're going to use for vector search. Another important thing to notice is that we have this create custom index down here, and this is creating an index on our product vector column, and it's using an SAI or a storage attached index. Now, if you've used Cassandra before, an SAI index or SAI is different from a SASE index, and it's different from a secondary index. It's also a lot faster. So, you may have heard some horror stories about querying Cassandra by secondary indexes before. Those do not all apply to an SAI or storage attached index. So feel free to use those. But again, it's always a good idea to use those at a limit so that, you're really not taxing the cluster that much. But anyway, if I go ahead and say, let's do a select star from product vectors, and I'll just say limit, we'll just do a limit 1 on this. Now, when I hit enter here, what you're going to see is that, yeah, this 384 dimensional vector is taking up most of the output space here. But what you can see is this first product here is this DSH 916 XL. It's a DataStax black hoodie. And here is the vector embedding that was generated for it. So we've gone through our vector embedding generator, and we've created these embeddings and we've put them into this table. The next idea is that we're going to switch over to the actual website code here. So this is the product REST controller that I have that just handles a lot of the product data endpoints behind the scenes. And what it does, and this one in particular is called get promotion product. So what you'll do is you'll take a product ID. And the way that I have this working is that when you add a product to the cart, it takes that product's ID and sends it to this. And the idea is that's going to do a find product vector by that ID. So really what it's going to do is it's going to go in and return, it's going to return that to you right there. All right. And with this, you can go ahead and feed that back into a vector search method, and that'll go ahead and pull back all of the recommended products. And you can see that where I make sure that it actually comes back with something. But here we say find products by vector. And if I jump over to our API services layer, here's the find products by vector method. It's using the DataStax data API. The data API is really just it's kind of like a way to work with Astra and DSE, HCD, Cassandra data in like a document paradigm. So think MongoDB, but it's about 90% Mongo compatible, which is still pretty good. But the idea here is that we're going to go ahead and we're going to do a find without any search criteria. But what we are going to do is sort based on the product vector, include the similarity score, and we're going to enforce a limit based on whatever was provided inside the method, and return that as a list. That's kind of how that works. So if I go back to here, and so we make sure that our result set has at least one in it. And see, and this is where I kind of talked about understanding your business logic and your data. I have a comment in here. I kind of detailed that out. I'm like, hey, the closest matches for clothing will likely just have different sizes. So we'll iterate through the list until we find the first product with a different product group. And again, that's something that I happen to know about the retail industry and kind of how they do their web marketing in terms of like the different products at different sizes. So I know that I need to pull back something of a different group. Otherwise, if I add like the DataStax black hoodie size large, I'm just going to get the size medium as my top recommendation, which, for me, that's going to be a little bit of a tight fit. So I'm not going to, medium is not going to do it for me. All right. And then we go ahead and we return that, and that's that. So if I go ahead and let's run this and take this for a spin here. All right. Oh, that's okay. That had an issue because it couldn't find its pulsar topic, which is something I use for. Oh no. Oh, I might have a version of this already running. Oh yeah, look at that. Okay, sorry about that, folks. Hang on just a sec. And there we go. Okay, back to here, and let's give that another shot. And this is actually configured with my my data API endpoint and my token and everything else I need to talk to the Astra database that we were just having a look at. Okay, that looks like it's running. So now, if I jump out here and say localhost 8080, oh, hey, look at that, it comes up. All right. One of the things that we did as a lesson while building this site was to build in like single sign-on with another provider. Like, you can add like Facebook. Excuse me, Facebook is a common one. GitHub sometimes. But we just went ahead and created Google. So, this is, I'll click that and then I'll pick my DataStax Google account. Okay, now we're in. If I go ahead and say, I want this Apache Cassandra 3 contributor t-shirt. There we go. And I can say extra large. Now, when I add it to my cart, what it's going to do is take this product number and it's going to run it through that logic that we just saw. So it's going to go ahead and say, hey, take this product, find it inside the product vector table, get me back the vector. Now we're going to go ahead and do a vector search, and I want the first product that's not in the same product group. So if I go ahead and add this to cart, there you go. You can see we get a t-shirt that comes back and says, you might like a t-shirt that says, go away or I'll replace you with a Spring Boot annotation. So I wish that was a real shirt. That'd be kind of cool. Anyway, so in a nutshell, that's kind of how it works. Oh yeah, this is a good tip there from Bill. Just notice that as you develop similarity search applications, and determine the vector for a search. And when you reuse it, you'll actually avoid like token consumption, which is pretty good. Definitely something that you want to concern yourself with. The idea with this approach too is that really, the only time that you're hitting an external service is when you're generating your embeddings. Once you have your embeddings and they're stored in your database, if you're not doing anything else specifically through an LLM, it's really just a database interaction model from there on out. So that's something to keep in mind too. Not that I'm running up our AWS bill on the company dime here or anything like that. So anyway, so this is a little bit of a view into how this works with just recommending a single product. The other approach we talked about was perhaps seeding this with some data from the customer's orders. And I have a similar endpoint here that'll do that. And I just call it get customer promotion products. The idea is that it lists out the user's orders, goes ahead and makes sure that it has a list of the unique products. I have, let's see here. Yeah, I use a binary heap here, and I have a comparator set up that allows it to go ahead and sort the results with the highest quantity first. So if there's a product that the customer has bought several times, it'll go ahead and kind of weight those products towards the top. Again, that way it's more the search results will be more relevant based on what that customer is looking for. So here we go. A binary heap structure in Java is one example of one is a priority queue. So I've gone ahead and kind of keyed it up with the order product object or class there, and and we can kind of go from there, and it'll go ahead and return like kind of the top products that are related to whatever the customer has inside their order data. Now, unfortunately, I don't have a visual of this one working just yet. But this is just a GET request. And if I'm logged in and authenticated through Spring Boot, it should allow me to do this. So, oh, yeah, here we go, because I've typed this before. Products, promo product, and then I have a customer ID, which is mine, and then I do a /customer. And we should be able to run this. Yep, there we go. And it's just an HTTP GET, behind the scenes. And you can see that let's see. Do we have? I'm trying to see if I was smart enough to include the similarity score in this one. I don't see it off the top of my head here. But anyway, you can see that the product ID is coming back. You can see the vector that is coming back. And each of the products that are coming back are related to what was existing in my carts that have been converted into orders. So that's a little bit of a distinction there. Yeah. Let's see. Do I have anything in here right now? Oh, cart's not loading. Oh, yeah. You know what? Yeah, I was trying to add that to get it to show up in the cart, and I must have hosed something. Oh, yeah, I did hose something up. Okay. All right. So we're not gonna be able to see that part, but that's okay. All right. So one thing that, let's see here. Let me jump back. And let's have another look at this this test embeddings code. Somewhere around here. Yeah, here we go. I have this data product ID name CSV. I've basically taken that same product data here. I can get out of here now, actually. And let's get out of that. And let me get that back down to 100%. Let me switch. Oh, there we go. Let's switch over to LangFlow for a second. So I've built this AI shopping assistant. We actually used it at AWS reInvent in 2024. So this has been out there for a little bit. But if you haven't seen LangFlow, I highly recommend check it out. As you can see, I mean, it might be a little difficult to see. I will zoom in some. But this is basically just a component-based drag and drop GUI for building GenAI applications. So I highly recommend checking it out. And for those of you wondering, yeah, you can go to this. You can click the code option, and you can see the Python code that's behind each of these components. But the idea here is that you can see I have this products2.csv. That's basically the exact same file that I was working with in that embeddings generator code. And the idea is that I'm going to run this through the Amazon Bedrock Titan Embed Text V2, and we're going to store that inside of my AstroDB instance, just like that, in a collection called AI Vectors. Let's see here. Do I still have? No. Okay. But this is what we call our data loading flow. So I don't want to run this again because that's going to kind of like duplicate the data. But what I will do is work my way up to the chat flow here. You can see that again I have this Amazon Bedrock embedding model here for the Titan Embed Text V2. I have our chat input, and chat input is pretty simple. It's just, this is for testing it out. It's like, hey, can you help me find a hoodie? Easy enough. Run it through AstroDB. Kind of the main thing, kind of another main thing to focus on here in the chat model is this prompt component. Now, you've probably heard a little bit about prompt engineering, but what you can do is you can go into here and you can say, this is how you give guardrails and instructions to the large language models that you're working with. You can say, hey, you are a shopping assistant for the Astra Apparel online store. You must only answer questions about Astra Apparel products. You can only use the product data in the provided context. Can't use any other sources for answers. That one's important. And you must format your responses about product data like this, like product ID, description, image. That's actually important if you're going to have LangFlow with its API exposed sitting behind another application, which I've also done. That's how you can kind of get it to produce consistent output. What I'm going to do next is kind of go up to this, this model component for Bedrock again. But this is more about the chat model, not so much the embedding model. And for this one, we're using Anthropic, Claude 3, Haiku. I want to say this is like V1. Yeah, 2024, March 07, V1. There's probably a newer one for this, but it works just fine. And then, of course, you have a chat output, component as well. And the idea is that when you go to the playground, oh yeah, you can see I said, hey, can you help me find a hoodie? And it has examples. These are some hoodies from Astra Apparel, and it kind of lists them out. I can say, can you help me find a Cassandra shirt? And this might take a little bit to chew on. I do see that a question has come up is can this be used in production and is it scalable? To be honest, I know that we have a disclaimer when you go into LangFlow. It says, hey, this is kind of a prototype. I wouldn't put it in a situation where it needs to handle 1 million requests in less than a minute or anything like that. But if you have something where it's getting hit, I don't know, even one time a second is probably okay. But the main thing that you're going to run into with something like this is the again, kind of like Bill mentioned, is that the costs associated with running it through your model provider is going to be the probably the foremost thing that comes up in front. And I see this is spinning quite a bit. Yeah. Sometimes it's not exactly snappy. Although I am running this on a free account, we do have ways, now that I think about it, to scale it out for production customers. But it definitely is one of those things that I would say, hey, this is cool, and use with caution. Come on. See, the nice thing about this too is that you could have something like this. Actually, you can say publish, and you can say embed into site. It has some quick web code that you could grab, and you could do something similar, even to just put it in like a corner of your website, and kind of have that interface opened up to going ahead and having that chat model around your product data. And there are certainly ways to integrate the results that come back to like actual real search results, or add to cart results. API access as well. I already mentioned that, but like they have Python code here that's kind of preset that you can grab, JavaScript as well. You can run a straight up curl command too, and that should do it. Let's see. Oh, hey, it did finally come back. Outstanding. So it has some Cassandra shirts available. There's a Cassandra 3.0 contributor t-shirt. There's one from 2023 that we did. I can't remember which one that one is. And then we have an Apache Cassandra vector search t-shirt as well. So this, kind of the cool thing about this Langflow example is this is driven off of the same data set that drives the website. And it's just another example of, something you can do if you take a generative AI approach to, building out and expanding your e-commerce site. All right. Okay. Well, like I said, I'd have some links available. This is a link to actually, both of these are GitHub repositories. The first one is the code to our e-commerce workshop website. Specifically, it's the one for the prototype that I've gone ahead and added on some GenAI features to. So I do recommend taking a look at that one. And then the test HFE embeddings one, that's the one that actually takes the product data, generates embeddings based on the product name, and puts it into AstroDB. It's named poorly. I apologize for that. HFE is Hugging Face embeddings. And again, that's both of these are Java projects, actually. You'll find too that that Java tends to be the language that I don't want to say neglected, but it's definitely not at the forefront when newer like LLM based tools are created. So if you're more of a JavaScript or a Python shop, chances are you're going to find some more mature tools out there than what I've been showing you here. I tend to pick Java, because it has a lot of use out there in the enterprise, and we traditionally at DataStax have a lot of enterprise customers who kind of want to know a path through the woods to continue on and kind of augment what they have in Java. But if you're doing a lot of new development in Python, you're going to find some great libraries out there that help you work with this too. So, all right, I think that's it. You know what? Let me. Yeah, back to there. Yeah. Okay. So I apologize if I mispronounce your name, but Thapilo. If you get into Langflow, this is kind of the warning you see that it's in public preview. So we have some preview terms there, but the idea is that yeah, you'll kind of want to at least understand that before putting it in production. But it's definitely something to think about. It's definitely a path forward. Let's see here. All right. Short of any other questions, let me have a look at the Q&A. Oh, yep, I answered that one already. Yep. All right. Well, if there's nothing else, that's going to be about it that we have for you today. So, if you haven't gotten too far into the, into integrating AI into your e-commerce site just yet, I highly encourage it. I hope I've given you some ideas and avenues that you can chase down here that might prove valuable. And hey, if you get stuck, feel free to have a look at some of the code I showed you, or reach out on LinkedIn. I am happy to help you out. So, hey, thank you everyone, and have a great rest